Today we want to look at the first big question that we deal with in calculus, which is what is the slope of the line tangent to a curve at a given point? What is the slope of a line tangent to a curve at a given point? If I have a curve we're going to start by defining the curve as a function because it's convenient for us to do so. So we have a curve and we have a given point. We are interested in the slope of the line tangent to the curve at a given point. So our problem is, what is the slope of the line tangent to the curve? What is the slope? What is the slope of the tangent line? What is the slope of the line tangent to a curve at a given point? So what we have is we have a line that connects to the curve at one point. The line only touches the curve at one point. If we think about the slope formula, we know that slope is rise over run. We talked about that yesterday, the R&R definition of slope. And that's change in y divided by change in x, or in formula form, y2 minus y1 over x2 minus x1. We immediately run into a problem if we want to calculate the slope of the tangent line. We want to calculate the slope of a line that's tangent to a curve. That means we only know one point on this line, the point where the line intersects the curve. We only have one point, but the slope formula wants 2 points. So there's our problem right away. It shows up right immediately. So the problem. Oh no. Slope formula wants 2 points. But we only know 1 point. We've only got this 1 point here where x is c and the y coordinate is f of c, whatever it happens to be. If we try to plug 1 point into the slope formula, we get 0 over 0, which is indeterminate. I have f of c minus f of c over c minus c, which is equal to 0 over 0. This is not undefined. If you have a constant divided by 0, that's undefined, meaning that it cannot be given a value. 0 over 0 is indeterminate. It can be given a value, but who knows what value it could be. Sometimes 0 over 0 is 1, sometimes 0 over 0 is 0, sometimes 0 over 0 is infinity, sometimes 0 over 0 is negative infinity. It could be whatever we want it to be, depending on the situation, which makes it kind of not useful. So we need a strategy to get around this. We can't calculate a slope with only one point. We get 0 over 0. That's indeterminate. So we're going to do the next best thing. We're going to approximate. We're going to do what we always do. Can't do this with 1 point, so we're going to use 2 points, and we're just going to make sure they're close together. So we're going to approximate the slope of the tangent line with a secant line. That's our strategy. We're going to approximate the slope of the tangent line with the slope of the secant line. So on our curve, we've got this point C and F of C, whatever it happens to be. And that's where we're interested in the slope of the tangent line. Problem was, we can't do a slope formula with just 1 point. So we're going to use 2 points. We're going to pick a point nearby. That will give us 2 points, and that will give us a line that's close, with a slope close to that of the tangent line. So we're going to pick a point nearby. I know this is hugely far away, but it's just a nearby. And we're going to find the slope of the line of this secant line. So we're going to approximate the slope of the tangent line with the slope of this secant line. Once we have a method for approximating something, we got to figure out how we're going to improve that approximation. How will we improve the approximation here? What are we going to do to improve our approximation? Once we have a method for approximating what we want, then we need to figure out how we can improve that approximation. In this case, what we're going to do is we're going to move the 2 points closer together. Specifically, we're going to take that nearby point and move it closer to the point we're interested in. So we're going to improve the approximation by moving the nearby point closer. This is how we operate. We're trying to figure out how to do something. We go with our best guess. We figure out how to approximate what we're trying to do. Then we figure out how we're going to improve that approximation. And then we're going to look for a pattern. Any questions? How's everybody okay? Also recognize that the problem that we encountered, we want to calculate slope. Slope requires 2 points. We only have 1 point. So we do the same thing that we always do in this scenario. We take our problem, I only got 1 point, and trade it for a problem that we do know how to do. There are 3 great tricks in math. There are 3 things. If ever you're stuck on a math problem, try to think of one of these 3 things to do. Number 1, add 0. Number 2, multiply by 1. And number 3, find a nearby problem. Reduce what you're looking at to a problem that you already know how to do. And that's what we did here. Problem that we don't know how to do, tangent line. Identify why that's a problem. Got 1 point, need 2 points. So what do? Get 2 points. Any questions? Is everybody okay? You all look so stoked. This is what you look like when you're all stoked being in a math class. That's where you all look like that right now. I don't care what face you think you're making right now, you look like this. It's totally okay. I'm used to it. My friends do it to me too. I think it was boring. What's funny is you try to communicate. It's like, Leach is going too slow. I'm going to give him my, I'm bored, so speed up face. And you look at me like this. Or sometimes I'll be going too fast and I'll say something that doesn't make any sense to you. It's like, I need to tell Leach to slow down. I didn't understand what happened. I won't use words. I'll just communicate it with my face. So you give me this face. Some of you have excellent college skills and you can sleep with your eyes open. So you're just kind of like. Some of you have even better college skills. You can sleep with your eyes open and your hand on your paper and your hand moves every once in a while. And the ultimate goal is when there's a pause in what I said, you subconsciously analyze and you like nod. But you're sleeping the whole time. That's like the highest attainable skill. You don't really want to get that far. That's too far. Because what happens is you become catatonic and locked into the classroom. Like if there are some certain rooms that you've never seen unlocked, that's because there's some students in there that we can't wake them up. I'm just kidding. We have a storeroom for that. That's why the desks are on wheels. I just called down. Dr. Folsom, I did it again. It's like, oh shit. And then like security comes in, they just like wheel this catatonic student out, put them in the warehouse. Remember that scene at the end of Raiders of the Lost Ark? Yeah, there's like a big warehouse. We just crate up that student. All right, to this end, I have some problems for you to work on concerning this slope. So we're going to do, what's this? Actually, I didn't put the N in there. So I am going to pause the recording and I have some problems for you to work on.